All right, I want to give a little bit of help with the current homework. So I'm going to focus on the case n and e is equal to 4, and I'm going to look at, if I call that function n dn dp, now the specific function that is relevant for n and e equals 4 is the function shape 4, the 4-node element, as a function of p. Remember here that p is the same thing as kz in the code. So if I draw that element, I have 4 nodes, 1, 2, 3, and 4, and I'm going to just focus right now on n3 as a function of kz. And let's work on how we derive that function. So n3 has to be equal to 0 at node 1, 2, 4, and then equal to 1 at 3. And we need to make sure we know the coordinates here. So the coordinate here is -1, the coordinate here is +1, and then they're equally spaced, so -1/3 and +1/3. And so then there's a difference of 2/3 between each of the nodes. And the function will look something like this. The way we define it is we first set up a fraction where the numerator is going to be terms that vanish at each of nodes 1, 2, and 4, everything but node 3. So kz plus 1 is equal to 0 when kz is -1, and kz plus 1/3, and then kz minus 1. So these terms vanish at nodes 1, 2, and 4. And then to make this normalized, or in other words, when I plug in the value of 1/3, I need this function to be equal to 1. So I can just add those terms in here, 1/3 plus 1, and then 1/3 plus 1/3, and then 1/3 minus 1.